Hi, my name is Tara Elise, and I will be teaching determinants. I will be teaching determinants with a 2x2 matrix, a 3x3 matrix, and in addition, a 3x3 diagonal. So when using determinants, you can only use them with square matrices, and a square matrix is something that is 2x2, 3x3, 4x4, etc. But today I'm only going to be teaching determinants with matrices of 2x2 and 3x3. So I will also be covering minors and diagonals. Method 1, I'll be teaching second order determinant. And method 2, I'll be teaching third order determinant. And some terminology we need to know. A second order matrix is 2x2, is a 2x2 matrix. And a third order matrix is just a 3x3 matrix. So that's just some terminology we need to know. So with a determinant, when solving, we will write our equation as determinant, bracket, A, B, and going down, C, D, or we could also use A, B, going down, C, D. And notice that these are just straight lines, and then these are in the brackets with a determinant on the outside. So both of these mean cross minus cross, which means I will just be taking AD minus BC. So if you need a visual, you will just be taking this and this, and we'll subtract AD minus B times C. So here is an example if we need to actually put some numbers in it. Example. So this one is going to be minors. This is minors, and then find the value of 7936. So for the visual learners, we will be taking 7 times 6 minus 9 times 3. So 7 times 6 minus 9 times 3. 7 times 6 is 42, and 9 times 3 is 27. 42 minus 27 equals 15, and that is our answer. Another example, we're going to find the value of x. So just as you can use it to find the value just with numbers, you can also plug x's into the equation and solve for x. Our equation will be 2x, then x and down will be 2 and 3, and we will do cross minus cross. So our equation equals 6. So that we're trying to solve for x. So our equation will be 2x times 3 minus 2 times x equals 6. 2x times 3 is 6x minus 2 times x, which is 2x, equals 6. 4x equals 6 because 6x minus 2x is 4x. And then if you divide each side by 4, you can get 6/4, or that can reduce down into 3/2. And so that is our answer. Just one more example that we can do. We can actually go back and just do it with numbers. So we'll find the value of 3, 6, -1, 2. So we will take cross minus cross, if that gets drilled into your head. And so we have to solve. So 3 times 2 minus -1 times 6. You get 6 minus a -6, and 6 plus 6, because you're subtracting a negative, equals 12. So the value of this determinant is 12. Okay, so this is now for minors' third order determinants. So when doing a third order determinant with minors, it's going to be laid out a little bit differently. We're going to have our line with A1, B1, C1 all in the first row, and then in your different columns you have A2, B2, C2, and A3, B3, C3. And a little note, to find the minor of an element, delete temporarily the row and column which the element is in. So to find the minor of an element, delete. The key is temporarily. And the row, sorry. Delete temporarily the row and column in which the element is in. So let's say we were trying to find the minor of A1. So A1, if you look up here, is in the first row in the first column. So if I wrote this out again, A1, B1, C1, A2, B2, C2, A3, B3, C3, and you look, our A1, first column, first row. So if you temporarily take out this column and this row, what we will have remaining is just this. So if you come here and you hide this and you hide this, all we'll have left is B2, C2, B3, C3. So the minor of A1 is B2, C2, B3, C3. So we plug numbers into it. Our example is find the value of 8, 9, 3, 3, 5, 7, -1, 2, 4. If you're trying to find the minor of A1. Sorry. Or of just the first row. The first row, yes. Which means the 8, 9, and the 3. So, when doing the math, we would have 8. So you're pretty much covering up everything else at the 8. So that if you cover up the 8, you won't